So that's how we hook up the state in React. Pretty simple. But again, this is a Recoil and Jotai comparison, and so far we've done a lot of React. But I just wanted to kind of point out, what it takes to get something like this in React going. I also wanted to point out why we might want something like Recoil or Jotai. Let me get this a little bit smaller and add a ton more elements, maybe not a ton, but several. So basically, we haven't done any sort of optimization at this point. If we go back into app.js and we look at these elements, we have to put these up in the highest thing that we can that sidebar and canvas both have in common, highest ancestor, and that's app. And so we're actually declaring them here, creating them here, and passing them down into each of those. So basically, anytime any of the elements change, it's going to be changing this whole thing. Now, we could go ahead and memoize these, but we're memoizing a bunch of different stuff. We're checking the X, Y, the width, the height, everything. In this case, nothing's really slow, but I do want to highlight what actually is happening just to point out why something like Jotai or Recoil might be useful, a circumstance in which that'll happen. So basically, I'm in the React DevTools right now. If you install the DevTools from Chrome or Firefox or whatever, you can see that there's a components and a profiler. I'm on the profiler. I'm going to click Start Profiling. So that means it's basically recording all my interactions. I'm just going to move this guy. That's all I'm going to do. And then I'm going to go ahead and look at this, pull it out, and made what's called a flame graph. And basically, it's showing that there are 173 different renders, basically, which is because every single time I move that, I was updating state. So that's not a big deal. But what is interesting is the sidebar. Every single one of these elements renders on every single commit, basically. Same with the canvas. Every single draggable and every single close button is all recreated every single time. So again, in this case, we weren't really suffering too much, but you can imagine something like, like a Figma or whatever, that could be just a lot of, computation, and that could really slow down what you're trying to accomplish. So what we're going to do is we're going to take Recoil and Jotai and use atoms so that we can just bypass that entirely. We're not going to have the store basically set inside of the app component. We're going to separate it completely and have this other store that we're going to use. And so we're going to see how exactly that works by going back into the element state. So we're going to have to adjust a couple things. So bear with me. This may take a little bit of work to get there. So the first thing we're going to do is we're going to import some things from Recoil. And the first thing we want to import is an atom. I keep using this word, so we're just going to go ahead and pull one out. And we're just going to take these atoms and let's create our first one. So they're pretty simple to create with Recoil. We have const element IDs atom, and this is basically, I'm going to keep track of every single ID. And if you didn't see before, I didn't even really highlight it, but basically we're using UUID, which means unique, universal unique identifier, something like that. Unique universal identifier just creates a unique ID. So basically, this will hold all the IDs of all our atoms. So we're going to say atom, and then what you have to do with Recoil is you have to give everything a key. I like to just copy and turn this into a string, whatever the name of the variable I have is. Usually I'm not repeating variable names. I try to avoid that, at least inside of a file. And usually I'm setting all my atoms up in one file. I'm sure if a project got bigger, this could become more of a problem, but we could even use this UUID function and create some keys if we really wanted to. We could figure out other ways to do that. And then you need a default typically, and our default is an empty array because we're just going to be creating these atoms. Okay, we can see everything went away. So we've got that, we got the default, and usually I like to make little helper functions. So we're going to have function use element IDs, and then what this is going to do is it's going to return use recoil state. So this is how you actually hook up an atom to a state. So actually what this gets, I should show before I return it, is it basically gets your state and your set state. It's very, very similar to the basic React stuff. So in this case, it'd be element IDs and then set element IDs, and you can just set that however you want. But I'm just going to pass this along. I mean, this is pretty simple. Even creating this, maybe is a little bit more overkill than I want, but I don't know. I like passing down one thing rather than passing this in and then remembering to call use recoil state and everything. So that's why I'm doing it that way. Just a personal preference. So let's create another atom that we need. We need, const elements. And then we're going to call this an atom family. So what an atom family is, it's a pretty simple idea. It's just kind of a collection of atoms, basically, and they're all I haven't done anything with it. Basically, they're all kind of namespaced by different params. So we'll get into how that looks exactly in a second. So again, we need a key. This really is just basically an atom at the end of the day. So we need a key for that. And then here we need a default. And in this case, it's just going to be undefined because I don't really care what the default is here. But basically, every atom we create in this will automatically be undefined. And then we also need a function called useElement. And in this case, it looks very similar to what we had here. But instead, what we have to do is, of course, take this elements atom family, and we automatically pass the ID in. So now we have the value and the set state for any atom that we want based on the ID. And then this use element, we can again pass it on to here. Let Prettier clean everything up for us. So we got use element, we got use elements. I think this is what's actually supposed to be up here, just to keep things a little bit more co-located. And then what else do we need? Well, we're going to need some other stuff, but let's go ahead and start thinking about how we want to actually hook everything up. So we've got all these action types, and I actually really like these switch cases and kind of reducer style stuff. I think it's easy to think about things in this way, and if you're already used to React, then it's going to be extra easy. So we're going to actually kind of keep what we have here. I'm just going to go ahead and delete a couple things. So this is going to definitely break our app, but the first thing that we don't actually need anymore is we don't need to change element attributes, and I'll get back to why we don't need that. Basically, I'm going to delete everything that is referencing that for now. And let's see, we've got one right there. So it doesn't like that because it wasn't exported, so I guess let me add it back and then export. Basically a no operation. I guess I'm not thinking about this exactly correctly. Okay, so it's a function and it just returns. That should work out fine for us. So at least that'll fix things for now. So we've got our add element, remove, start, stop, and drag. We want to keep all of those, but then we want to use something else that comes from Recoil, and it's called a selector. So a selector is just a special atom, but basically it's an easier way to kind of tie multiple atoms together to either get a derived value from or even a derived setter, which I personally find a lot more valuable than the derived atom itself. I like to keep atoms pretty autonomous. As I can. Some people like to make big atoms and then create these specific selectors that pull the things out. If you don't really know what I'm talking about, just go through the Recoil docs and they'll show you all sorts of examples of this stuff. Basically, I'm going to show you a pattern that I've been developing that I really like. So we take this selector. What we're going to do is we're going to come down here and we're going to say const dispatch selector, so you can maybe see where this is going. So you can add a getter, and this could be a very specific thing that pulls out a specific state that you want or whatever, but honestly, I don't actually need that in this case. What I really want is I want the setter. How this works basically is you can pull off these two nice little functions here called get and set, and we're going to get back to those. You can also additionally pass any parameters you want in here, and I'll show you how this is going to work when we hook it all up. But for now, basically just, take my word for it that the second argument is whatever you want to pass in. We'll pass in an action, and then this can just be a function. So what we're going to do is we're going to actually take this big switch statement that we had and pull it up here. Of course, none of this is going to work correctly, so we're actually just going to delete all of this stuff and keep the breaks in so that everything still works on that end. Great, so we've got all that. Oh, I deleted one too many lines, and that's perfect. So the other thing that I want to do is I still want to use Emmer because Emmer is very nice, but I want to create some little helpers for myself. I've got two separate atoms, and I want to be able to update them very easily. So what I'm going to do is I'm going to create simple little ways to update them. So the first one will be called const set element IDs. It'll take in a recipe. This is kind of a terminology that comes from Emmer. Basically, it's a way to describe just a function that describes how to update the state. So take that recipe, and then we'll use this set that came from here. And how this set works, it's really nice. You just pass any atom you want, so element IDs atom. And then the second thing you pass in is basically how you want to set it, and it'll take in the previous state. So since we're using Emmer and using the produce, we can just pass in the recipe. And what this does is it takes an old version of the state and basically applies the recipe. So basically what this is doing is this is creating a function with that recipe, and then it's using the previous element IDs. So it's taking that. So it's pretty much applying this recipe to these, and then whatever the result of that was turns into the new version of it. And then that new version is what's evaluated here and passed into these element IDs at them. So again, if that didn't really make any sense to you, don't worry about it too much. I guess the other way I could write it is, preval So the previous values, you pass them in. Basically, you could say pass them into here, into the produce, and then your recipe would get called with them. That's pretty much what it's doing. So it's just shorthand for that. That's how we can just make a simple set element IDs helper. We're going to do a similar one with the specific element. So const set element equals ID recipe, and then we'll pass set with elements atom family and pass in that ID, and again a produce with the recipe. And we should be good. So let's start adding a few of these. So we want the add element first. So let's set this one up. We're going to say const new ID. We're just going to go ahead and get the the unique identifier out here, and we'll say set element IDs. We'll take the draft, keep with that terminology. We're going to say void draft.push new ID. So basically we're doing void because this is inline. We don't actually want to return back anything, because if you return anything in an emmer function, it will automatically use whatever you just returned, which in this case would be a number. So we're just saying, hey, don't worry about that. I am updating, the draft. Use that new version of the draft. That's the idea there. Set element new ID, and then a recipe here. And the recipe doesn't need any the draft. It's just going to create a new element, and then pass in action.x and action.y. So again, if you remember our original add element, we were taking an x and y, and we're creating the element with it, and we're doing the exact same thing. And now create element, we don't actually need the UUID to be held in here, so we can delete that off of that and be happy with that. So of course, I like to kind of make sure things are working as we're going, because otherwise, I have no idea if anything's actually working. So I very much like a fast feedback cycle. So let's go ahead and get all this hooked up. So the first thing we're going to want is we're going to want a function called useDispatch. And there we're going to say const dispatch equals useSetRecoil state. So here, this is different than the useRecoil state we were using before. This is just getting the setter. We don't actually get any value because we define get as null. We don't need that. It's very useless. While we're down here, we can grab this guy and return dispatch. And there we go. So we got useDispatch, and we want to export that so that we can actually, again, use it. So now we actually want to hook it up. Before we were doing this use elements, but we want to do this a little bit differently. The first thing that we want to do is we want to go to app, and we want to, instead of use elements, we're going to use element IDs. We're no longer going to export this app. We're actually going to call this something different. We're going to call it content, very original. And we're going to export default. That should be deleted. We need a new function. In this case, we're going to call it app again. So the reason we're doing this is because we need to return recoil root. So for recoil to actually work, you have to create a root. This is where all the stores and the atoms and everything are held. And in there, we're gonna pull all this guy out of here. We close that one off. I think we had another one to close off, and then we're going to render this content. And so in here, we can say, hey, we don't need any of that anymore. We are going to need some fragments just to make sure everything works correctly. And let's see. All right, good. We're getting the linting errors that we expected. So we no longer want elements. What we want is we just want the element IDs. And so we're destructuring this because this use element IDs also gives us back the setter, but we're not using the setter. The only time we're setting is inside that switch statement we had. Now with these element IDs, we are going to pass these along, pass them along here. And so we definitely need to change a couple of things here. So we still want the key, we still want the ID, we still want the title, but we don't actually want any of this for the element inputs. And we are going to adjust that in just a second. Actually, in fact, let's do that now, and we're going to comment out canvas. So canvas is gone. Let's go to element inputs. Again, we deleted this. For now, let's just do a const dispatch, so this is no longer mad at us. This is a no operation, no op function, just to make everybody happy, so no one is mad at us anymore. And then we want to get the specific ID, the specific element that we need. So now we can use our use element ID. And with that, we can have a bunch of stuff that we're going to get off, but also we can, more importantly, get the set element. And this is why we no longer need this change element attribute. So we're actually going to get rid of that completely because we're going to use this set element. specifically. And so now the way that we can do that is we can take these attributes, we don't need the dispatch anymore, and we don't need this anymore. So what we're actually going to use is we're going to call the set element that we had. Oh, it looks like we're not even using that anymore. So we got ID, we got new attributes, which is good, but we're going to do this actually a little bit differently. We're going to call produce from immer. Let's see if that imported correctly. Good. We're going to call produce, and then what are we going to have? We're going to have the draft, which is the previous state of this, and then object dot assign the draft with the attributes. So we take in any new attributes, and we're just going to assign them onto the draft, and it works perfectly. Now let's get all those things that we deleted before: X, Y, width, height, and color. And so now we've got all of those, so that actually should work perfectly. So we'll see those come up here in a little bit, but we do not have them quite at the moment, but we will be getting there. So now we can go back in here, we can make sure that we delete this, and everyone should be happy. This should not blow up anymore. But we still don't have anything hooked up, so I feel like we got so close, but there's still some things that need to be done. So it's not super easy to switch from React to Recoil. I would definitely recommend starting with Recoil if you know that you need it, because there are some things that you have to do to hook everything up, and it can be a little bit of a pain. Some other things that we want to do a little bit differently is we want to map over, instead of mapping through or rather passing these elements into the canvas, we're going to delete these things. We're going to do something similar to what we're doing with the sidebar here. We're going to actually pass some things directly into it. We're going to get these draggables, which means that we're going to have to do some different stuff. So in this case, I'm actually just going to copy what I have here because I feel like this is going to be a little bit easier. So we have the element IDs, which were used up here. We're going to need this draggable. This draggable should come from Canvas. So we will fix this in a second because we're not exporting any of those. So we have the draggable, it needs a key, it needs an ID, and then the element, basically this is just saying, hey, double click. We should see that again once we get everything fixed. So here we're no longer passing that stuff down. We're not prop drilling anymore. We're just passing it into the direct children. So we can save that off, but we need to go into this file and actually fix some of this stuff. So first of all, we are not export default. We're not doing that anymore. Because we don't have a default, we're exporting a couple things here. So first thing that we need, we got rid of all this I just said. So we're going to delete all of that. We do not need this anymore. We do not need this anymore. And really, we don't need any of that. Let's get rid of that and let's export this. So it doesn't work yet, but we'll get there. So we're gonna have dispatch equals use dispatch. We already know we want that one. Nothing else here really needs to change quite yet. The only thing that's a little bit different is we need to pass along the children, any children that were passed down to this. So that is the one prop that we're adding with those children. Again, to remind you, the children are now all these little draggable events. And good, our double click to add an element, that came back. So that's awesome. So if we go back into draggable, we want to adjust this. We really don't need actually any of that. We're going to pull that out, and what we do need is we need the ID. Because what we're going to do here is we're going to say const use element. That's really what we want. We're going to pass the ID into that. And then in here, we're going to pull out a bunch of different things. So I saved those earlier. We don't actually need all this. This doesn't all make sense. And of course, this is mad because I've got some commas going crazy up here on these imports. So the X, Y, width, height, color, on mouse down, on mouse on delete, those are not quite right. So we'll take those off because those don't actually get exported from there. And then we want our dispatch. Use dispatch, we're good. We got a couple of things mad, so that on mouse down, like I said, we're gonna fix that. So we can get the event from there, and first thing we're gonna do is we're gonna say prevent default, and then we're gonna say dispatch. What we had before was actually start drag, ID x e dot client x, and then y is e dot client y. That's what we want with that start drag. And then the on delete was, it was pretty simple. So it was just dispatch remove element with ID. And there, everything is, quote unquote fixed. So next one to do is to do this remove element. That one again should be pretty straightforward. There shouldn't be too many gotchas on that one, I wouldn't think. So what do we want to do? We want to do set element IDs. Let's take that draft. With that draft, we're going to say get the ID from the action. We're going to say const element index equals draft.find index. Oops. And then element ID equals ID. So that'll give us the element index, and then we can say if, I still spelled this wrong, element index. If the element index equals -1, we're going to bail again. Otherwise, we're going to do our splicing. So delete that first element, and that will remove one. And then we got our other three, which aren't going to be too hard. They're actually very similar to what we had, but we're just going to go ahead and type them all out. So const ID, we need the X and the Y. This all comes from action. And then we're going to say const element equals get elements atom family. So we want that individual element. And we're going to say if the element equals undefined, then we'll return. Otherwise, what we want to do is we want to get the diff x element.y. Again, this is really everything we did before, so this part we could have probably just kept the exact same. This should be a minus. That should be x, and this should be y. Here's the problem though. We have this diff x and this diff y. Previously, those were on this initial state, but we don't really have this big high-level state anymore. So let's actually create another atom. So this is a nice thing with atoms and with this selector is you can just kind of create more atoms as you need them and then combine them all in the ways that you need them inside of a selector so that they all use each other, but basically you don't have to be subscribed to them all together in a specific component. So what we're going to create there is we're going to create a const drag element atom. It's going to equal an atom with a key, drag element atom, and we're going to say that the default is an object with dragging ID null, diff x null, diff y null. And there we've got it. Now we don't need to export a user of this because this actually is an implementation detail basically. We're not really exposing this. I don't want them to know who the dragging ID is or the diff x or the diff y. This is really just for my nice little switch statement over here. So we're going to use it accordingly. We're gonna make one of these though. We're going to say const set drag element. We're going to say equals recipe, pass it along, set drag element atom, and then produce with that recipe. Cool. So we got a set drag element, and basically now what we can do down here is just say, hey, I want all my stuff. I want my draggable or dragging ID to be the ID. I want the diff x, and I want that diff y. And now the stop drag is pretty simple actually. So all we need to do is copy what we had before, and we're going to paste it in here and change all of these to nulls. And that will make our life very easy. And so we're good. So that should do that, but a mistake that we made is, if we remember correctly, the way we set this up is this actually needs to take in a callback. So I can't just update these directly. And this is purely a choice that I made. I made it to where you have to pass these in. And then of course it thinks that's the function body. It's not the function body. So then I'll pass these and wrap this in parentheses. And it should be happy now. So we just needed to pass in those recipes, even though those recipes are just complete replacements. So now we have the drag, and in this case, I'm actually just going to copy what we had just to show how similar all this logic is. We're just changing a couple little things. So again, you know, this isn't quite right. We can copy this. We have to go ahead and get from that atom the stuff that we needed. But in this case, sorry, I grabbed the wrong thing. It was supposed to be the drag element. So drag element atom. And so we can get that dragging ID, the diff x, and the diff y. If the dragging ID is null, we're going to bail. We can get the specific element. So we don't actually, this is a little bit different. So this is where I was copying a little bit too early. What we want there is just this. This is actually a lot easier in some ways. We don't have to find over a big list. We can just pull out the specific one we want because that's how atom families work. You just pass in the ID that you need. If the element for some reason doesn't exist, we're going to return. That default, again, was undefined, so that really is what it's going to be if it doesn't exist. We got x and y, or if it was never set. From the action, then we could say, we don't want this object assigned. We want to say set element, and we need the dragging ID, because this is how set element worked. We had to pass in that ID as well as the recipe. And so the second argument is not going to be an object, it's going to be an ID where we're setting x and we're going to set y. But in this case, we are actually going to take the draft. See, I deleted things a little too early. Say object.assign the draft with this new thing, and one more parenthesis ought to fix everything. So now we should be good. Yep, everything drags. I can delete it. That's great. Let me change the color. That worked. Let me change this to 750. It's huge now. And then change the Y. Let's go a little bit up. Change the X. Let's go a little bit in. And we can even drag this giant square that I have, and it works. So not too bad. Let's make sure that this was actually worth it. First of all, let me delete everything that didn't matter and make sure it truly did not matter. So we've got use elements. It's mad about that, and we can delete that. And we don't need this. Oops, zoomed in a little too much there. We can refresh, run through everything. We don't have any tests set up, so we gotta manually test everything. Everything works though. This is all great. But again, let's pull up the profiler. Let's make sure this really was worth it. So we're gonna profile, and we're gonna add a bunch of stuff and make sure that this is actually working well. So we're gonna record and go stop recording, and pull this out. First of all, only 7 commits. Is a little surprising. I think it's, I have hide commits below 1, so let me get rid of that 1 millisecond. Okay, 285 commits makes a lot more sense, because every time we move the mouse even slightly, that commits. But if you look, I mean, there's just so much gray, did not render, because nothing really happened on these renders. So again, let me add this back, and let's just look at the ones that were important. So if we go to any of these individual ones, we can see there were changes, but it was only the specific element I was dragging the entire time. I didn't have to memoize or do anything special. Just for free, I got it to where only the thing I'm changing is actually changing. And this is where Atoms excel. When you have state that is really, needs to be shared across the application, like in the sidebar and in the main body in some way, and, you've tried maybe putting it in context or something like that, but it just either feels clunky or it's just not as fast as you want, or you're still having to do all this memoization. This is really when Atoms, shine.